Hello students, welcome back to our channel. Students, in this video we will discuss about trapezoids and the various properties and formulae and types of trapezoids. What is a trapezoid? A trapezoid is simply a quadrilateral having two parallel sides. For example, a typical trapezoid looks like this. Something like this. Okay, let me make it more clear. Okay, this is a typical trapezoid. So these two sides AB and CD are parallel, and AD and BC are non-parallel. So one pair of sides is parallel and the other pair of sides is not parallel. So that figure, that four-sided figure, that is the quadrilateral, this type of quadrilateral is called trapezoid. So we can define it like this. It is a quadrilateral having a pair of parallel sides and a pair of non-parallel sides. Right? So it is a quadrilateral having a pair of parallel sides and a pair of non-parallel sides. This is also called trapezium, right? So trapezoid and trapezium both are the names of this figure. So types of trapezoids. Types of trapezoid. First type of trapezoid is simply the scalene trapezoid, which means having all four sides of different lengths. A trapezoid having all four sides of different lengths, like this one. This figure clearly has all four sides of different lengths. Right? So the length of this side is different, length of this side is different, length of this side is different, length of this side is different. Second one is the isosceles trapezoid. Isosceles means the length of two non-parallel sides will be same. The length of two non-parallel sides, that is this side and I'll just draw it, this side. These two sides are of same length. These two sides are of same length. So we cannot say that an isosceles trapezoid is something which has two sides, any two sides of same length. No, if the length of these parallel sides is same, then this will not be trapezoid, this will become parallelogram. So the length of these two non-parallel sides should be equal, otherwise this will become parallelogram. So this is called isosceles trapezoid. And number 3, acute trapezoid. What is acute trapezoid? Acute trapezoid means the trapezoid whose both the base angles are acute, right? Okay, like this. So we don't have to draw because already the acute trapezoid is present on the board, and the obtuse trapezoid is a trapezoid whose one base angle is obtuse and the other base angle is acute, like this. Right? So this angle is what? This angle is acute angle and this angle is obtuse angle. So this is obtuse trapezoid, and the last one is right angled trapezoid. Right angled trapezoid. So what is a right angled trapezoid? Obviously, right, you have predicted it right. The one base angle should be 90 degree and other base angle can be of any value, this, right? Clear? Okay, so these are the types of trapezoid. So we will now derive the formula for the area of the trapezium or trapezoid. So let us say this length, okay, let me do some construction first. We will draw perpendiculars from C and D on AB. Now let us say the length of this smaller parallel side is A, that is the length of CD is A and the length of AB is B. Length of AB is B. And if this is A, then this is rectangle, right? This one is rectangle because these two angles are 90, these two angles are 90. So this one is rectangle. So if this length is A, obviously this length is also A. And let us say this length is X and this length is Y, the remaining lengths. And the height of this trapezoid is taken as H. So what is the area of this trapezoid? Area of this trapezoid is simply the sum of let us say this point is E and this point is F. So this is the area of triangle AED, area of triangle AED plus area of triangle BFC and plus area of rectangle EFCD, right? Okay, so what is the area of triangle AED? Area of triangle is what? It is half length of base, which is X in this case, into height, which is H in this case, right? Plus area of the other triangle. Area of this triangle is half base, which is Y, into height, which is H, plus what is the area of rectangle? EFCD. Area of rectangle is what? Area of rectangle is length into breadth. So it is A into B. Okay. So what can be taken as common from sorry, not B, obviously A into H. Area of this rectangle is A into H. Okay. So what can be taken as common? Okay, let's do one step more. So we want to take half common from all these three, and since there is no half here, we can multiply this by 2 and divide this by 2. So now we can take half common from these three terms, and we are left with x here and plus y here plus a here, and h is also common, right? Okay, 2a, not a, 2a. 2a and into h is also common. Now what we will do, if we write it as half x plus y and 2a, if we write 2a as a plus a into h, so it is half x plus y plus a. X plus y plus a is nothing but the length of this side, which is b, right? X plus y plus a. So this is x plus y plus a is b plus a into h, and this is the area of the trapezoid or trapezium. So this is what? This is a very common and important formula in mathematics. So the area of trapezium is half into sum of the parallel sides into the distance between the parallel sides. This formula can be remembered in this form. Area of trapezoid is half into sum of parallel sides into distance between the parallel sides, which is also called the height of the trapezoid. Height is nothing but the distance between the parallel sides. Distance between parallel sides. Distance between parallel sides. So area is half into, I am writing all the forms because these are the various forms. Formula is same, but different books write this formula in different ways. So some students know that the formula is half into sum of parallel sides into distance between parallel sides, or some says that it is half into sum of parallel sides into height, but both have same meaning. So this must be understood. Sum of parallel sides into height, right? So these are the types of trapezoids, the formula of trapezoid, the derivation of the formula of trapezoid. This formula is very important in maths and in science also, right? So just remember this formula, and you should know the derivation, because in case you forget the formula, you can derive the formula as per need. So I'll meet you in the next lecture. Till then, all the best.